Okay, so this lesson is going to be on cross sections and rotations. Okay, a cross section, make sure you're highlighting or underlining. A cross section is a surface that would be exposed by making a straight cut through something, especially right angles or axes. So, again, it is a surface or shape that would be exposed by making a straight cut through something, especially at right angles to an axis. All right. So our initial diagram here is a cylinder, and this cylinder is being cut parallel, meaning it's being cut left to right, which is parallel to the base. Okay, the base is at the top and the bottom. You have a base, one at the top, one at the bottom. All right, so it's being cut parallel there. So if it's cut parallel to the base, it's gonna form a figure when you take the top off, and that figure is shown here is a circle. That is the cross section that comes from it being cut left to right parallel to the base. Okay. Now a cross section is being cut perpendicular to the base, which will be from up and down or top to bottom, will form a rectangle once it is cut through the cylinder. Okay. So our whole lesson is to think about these type of shapes and figure out what type of cross section will be formed if we are cutting left to right or which is parallel or up and down perpendicular. All right, so let's look at example one. Example one says, what is the vertical cross section going through the center of the figure shown below? Vertical. Vertical means up and down. So if we're cutting up and down through this figure, okay, up and down through this figure, the cross section that you should see would be a triangle because when you cut up and down through a triangle and open up this figure, I mean, not through a triangle, up and down through this pyramid, when you cut through it and open it up, you will see a triangle. Okay. Example two, it says Daniel cut the corner of off a cube as shown in the diagram below. Points A, B, and C are the midpoints of the edges of the cube. What type of three-dimensional figure has been cut off? So we're looking at this section here. What type of three-dimensional figure has been cut off? We know it has three sides. Only one figure has three sides, and it's a triangular figure. So is it going to be C or D? If you chose D, you are correct. Okay. Then we have example three. Example three is a right circular cone is represented by the drawing below. Which figure could not be a cross section of a right circular cone? All right. So look at the figure and look at each answer choice. This will be easy to understand. If you cut it up and down, if you cut it left and right, if you cut it diagonally, you can see that one of these figures will not be formed. Which figure will not be formed? If you said D, you are correct. Okay. Example four, what three-dimensional figure will you get when you rotate a rectangle 360 degrees? Okay. I have a rectangle right here. If I rotate that rectangle 360 degrees like this, what figure would I create? If you need to look at your phone and use your phone to rotate it, then do that as well. But what figure would it create? If you said a cylinder, you are correct. Y'all, I need to learn how to write. Cylinder, you are correct. Okay? It will create a cylinder because these straight lines will form circles. Okay? They will form circles, and then you will have a cylinder as your figure. Example five, it says Kathleen rotated an isosceles trapezoid 360 degrees around its longest base. What choice could be the resulting solid? Okay, so if you do not know what an isosceles trapezoid looks like, this is an example of an isosceles trapezoid. So if she is rotating it 360 degrees, 60 degrees about the base, meaning rotating it this way, which type of figure would it create? Think about it for a second. And if you chose C, You are correct because these two ends will create cones, and then the middle, which is just like your cylinder, well, I mean, your rectangle will create a cylinder. Okay. All right. So let's go to our foldable that we have. And the foldable that we have cylinders here. So we're talking about cutting parallel to the base and cutting perpendicular to the base for each piece. So I want you to think about which figure you will get. So for example, number one, if I'm cutting, not number one, the top, if I'm cutting this cylinder left to right, which figure would I get? If I'm cutting this cylinder up and down, which shape will show me once it's cut? Okay, so for here from left to right, we're going to get a circle. And for this cylinder up and down, we should get a rectangle. Okay, this is our rectangular prism. If I was to cut my rectangular prism left to right through the base, then I am going to get another rectangle. And if I was to cut my rectangle up and down perpendicular to the base, we would still get a rectangle. Okay. Now, my pyramid, if I was to cut the pyramid left to right parallel to the base, I'm going to get a rectangle. And if I was to cut it up and down perpendicular to the base, it's going to give me a triangle. Okay? So I want you to look at the rest of this paper and tell me what figures you're going to create. Okay? What figures you're going to create by slicing it parallel to the base or slicing them perpendicular to the base. Okay? So let's see. For the cone, what are we going to get? Okay, so for the cone, you should have circle and triangle. All right. For the tetrahedron, you should have triangle and a triangle. For the triangular prism, if it's left to right, you should have triangle and a rectangle. Okay. So that's all you need to know right now about um, cross sections and rotations. All right.